Lunch and Learn is an MFG radio network production brought to you by GIE Media's Manufacturing Group. We highlight some of the latest innovations in manufacturing and design to help you gain insights to the newest products and technologies in the medical, aerospace, defense, and electric vehicle manufacturing industries to keep you ahead of the competition. Hello and welcome to the latest Manufacturing Lunch and Learn from GIE Media's Manufacturing Group. I'm Jake Kaufman, the senior editor. We're happy to be joined today by Iscar. Iscar is a full solution provider of metal cutting tool products and accessories for CNC machining, launching hundreds of new products for machining each year. Iscar is where innovation never stops. Patrick Klein is a national product manager for hole making for Iscar, and he joins us today to discuss precision hole making for medical manufacturing. Without any further ado, Pat, the floor is all yours.
Thank you, Jake. I appreciate that. And thanks everybody for spending part of your Thursday with us. And we're going to talk about some hole making, specifically kind of some of the smaller tools that we have for the medical industry. And as we go through this, like Jake mentioned, we'll have questions and answers at the end, and we'll try to get to as many as we can. So without wasting any more time, let's get started. So Iscar is a full-line supplier. We have a lot of hole making product. Obviously, we can't go through all of it today, and we'll try to focus on just the aspects of it that really lend itself to the smaller components that's going to be in the medical industry. You know, we use technology to manufacture things, and lots of things in the manufacturing world is changing, you know, with the advent of 3D printing and computational fluid dynamic software and other things like that. More and more cutting tool companies are working to constantly make improvements for the manufacturing process. And, you know, since the tool life is relatively a short part of the equation. Whenever you do look at manufacturing, you know, hopefully your expensive machine tools are going to last and last and last, and it's kind of harder to upgrade those. But your cutting tools, they're a perishable item. They don't last as long. So that's an opportunity where companies can constantly look to upgrade and improve their processes because it has a relatively short cycle compared to your capital equipment. And so Iscar, no different than other companies. You know, we use technology to take advantage of technology, so to speak, to improve things. And when you look at things, and here's a family of tools, and whether you use our digital stuff like our e-catalogs or even the old print catalogs or whatever, you know, anybody can go in and grab a tool, but is it the right tool? And that's really where we'd like to help people make good, educated decisions on cutting tools, because if you do that, then you have a good, consistent, repeatable process. And that's really what we're striving for. And whenever we say we want to be your productivity partner, we want to do that by helping you make those good, educated choices so that you have a good, consistent, repeatable process. And so whenever you look at, you know, we've got a bunch of different families of tools that can drill a hole, but is it the right one? And so when you look at it, you look at certain things like, initially, you're going to look at your drill diameter. Yes, it's the correct size. Hey, is the flute length long enough so that I can make chip evacuations and make the hole? But more importantly than that is, what's the hole tolerance? You know, if you start to stack the tolerances of an indexable type of tool, which has maybe a square or a triangle insert, and you take the tolerance of that, and you take the tolerance of the steel tool holder and all the manufacturing that goes into it, then what you look at is an IT hole tolerance of 12 to 13. And all Iscar product will be IT type of hole tolerance. And if you're not familiar with it, you can Google hole tolerance and get a nice chart off of Google. But as that IT number gets larger, so does the tolerance. And so, you know, you don't want to have a very tight tolerance hole and use, say, our DR Twist indexable. You might get lucky, and lucky being the key word, and you may make a couple of batches of parts, but then all of a sudden you're out of tolerance. And so the next thing is, and you can't get away from physics, is that if you have a single effective tool, you're removing less cubic inches of material per minute, and it takes so much horsepower to remove a cubic inch of material. And if you have a two effective tool, obviously you're removing more, and so it requires more horsepower. So you don't want to get too large of a horsepower consumption tool and try to utilize it, because then you can't utilize it to its capacity, and you're paying for something that you're not really using. And of course, the application, is it rigid? Is it not rigid? Is there cross holes? Or there what kind of features on it that could cause some issues? And so, just as a pictorial here, length diameter ratio, you can see there's a lot of overlap, but there's quite a few different drilling families that we have to go in and utilize. And so, the main one we're going to talk about today that really especially lends itself well into the smaller uh, parts, if you will, or components that would fit inside your body or be a medical component. We're going to talk about our Sumo Cam. It's our high performance two flute, two effective system. It's probably our most versatile system, and it has the largest width and breadth of product offering. And with that, whenever we look at this, it's self clamped. It is twisted coolant through. And the reason why it's twisted coolant through is because one of the limiting factors whenever you're doing hole making is your ability to evacuate chips. That more than anything, that's going to limit how fast you can drill. And so if you have a central coolant line through the center, if you take and it wise out on the end, if you take in cross section that, you would have a donut. And if you're not careful, you can go at a high enough feed rate that even with tool steel bodies, you could shear the body. So therefore, you'd have to reduce your parameters. So that makes it less high performance. Or the other thing you can do is shallow up the chip gullet so that that donut is bigger. But if you do so, then you have less room for chips. So again, you'd have to slow your feed rate down. So by having the twisted coolant, you're able to keep a small center core, as large a flute gullets as possible, and that way you get the maximum performance out of the tool. And so, Iscar, where innovation never stops, like Jake had mentioned, we're always updating. So in the picture on the left was our original cam drill, self-clamped, that we came out with that in 1999. And it worked good for the time, but, how many of you are still driving a 1972 Ford Pinto or Chevy Vega? You're probably not. You've upgraded since then. And the same is true with every cutting tool company. They're always updating and improving themselves, and the end user is the one that benefits from that. So now you can see the tool on the left is the Sumo Cam. And the Sumo Cam, you can see the larger orange pad that absorbs the equal and opposite force that takes place from the shear force of shearing the material. Well, by seeing the bigger orange area, you can tell that Sumo Cam can take more feed and takes more pressure before the pocket deforms. And also the resultant force from where the insert head is tightened into the body, it will be the green area that you see, and it's a larger area, and the resultant force will always be 90 degrees or perpendicular to the plane that it's applied to. So it's pushing it straight out instead of trying to spread, the end like the original cam drill did. And then also with the Sumo Cam, as the force is applied, that equal and opposite force is applied to the cutting edge. It goes through the head and it touches those orange support pillars that are green in this image. And the resultant, since it's on an angle, the resultant force causes it to pinch in and actually even bite harder whenever on the insert, whenever it's in cut. And so just some improvements within that. But whenever you look at this, you want to reduce variables in your process. And anytime you can, it makes your process more reliable and more repeatable. And one of the things is offset. So tools are going to wear, they're not going to last for forever. And so you have to change them out. If it's a conventional solid carbide drill, then you've got to touch off on the tool. That takes time. You have to reset it. It also allows an error to creep in there if somebody fat fingers the number or gets dyslexic or whatever, and the machine spindle crashes. And in the medical world, a lot of these machines are, the Swiss machines or the small spindle, robo drills, brothers, anything with the BT30, they make parts really fast. And so anytime the green light's not running, it's costing money. And so what we do is our tools are plus or minus 0.002 on changing inserts out. So once it's preset, you don't have to preset it anymore. So you reduce that variable and chance for mistakes, and you can quickly change it in the machine, hit the green button, and be back making parts again. We high hardness tool steel body. We're going to have the helical margin provides less room for chips to get stuck. They're high helix to help auger the chips out. They're polished for reduced friction. They're the twisted coolant. Everything that we can do to make the drill be as high performance as possible and make you be as productive as possible is what we're going to try to do. And that was the whole context of the Sumo Cam line and having the self-clamped insert head that goes in there. And so we call this replaceable head technology as compared to, say, a square insert that you index, and we call that an indexable type of tool. So whenever we're looking at this, what's some of the advantages of a replaceable head? Well, first off, with Sumo Cam, we go all the way down to 4 millimeter or 157 and up to 1 inch 295 or 32.9 millimeters. So a large range that you can drill. Hopefully, nobody's getting a medical component put in them that requires holes that are almost 1.3 inches. But anyhow, the heads come in 4,000 increments or every 0.1 millimeter. And so there's a lot of different head sizes. And from that, each body has a range of heads that will fit on it. So you have a 20 thousandths range of heads that will fit on it. So since the heads are in 4,000 segments, that means 5 different head sizes will fit on the body of a 587 or smaller tool. And above that, then you have a 40 thousandths range. So 10 head sizes will fit on it. We have a variety of edge geometries actually. And so some are meant to be problem solving, some are meant to provide a certain feature like flat bottom, others are problem solving like chip splitters, also material specific edge geometries for your nickel materials or your super alloys, stainlesses. I know cast iron won't be in medical, but we have those types of, as well as steel, we'll have those types of geometries. And then we have a bunch of different body lengths because you want to keep your body length as short as possible because it makes it as stable and carbide-like stability. It makes better tool life. And best of all, you do not have to regrind. And when you regrind, that's introducing a variable into your process so it's less repeatable and less capable. Tungsten carbide is the binder that holds cobalt is the binder that holds the tungsten, which is part of the alloying element that makes carbide. And so it melts at a lower temperature. So every time you put heat into it, you're degrading the quality of that cutting tool, and the tool life is not going to be the same. And if you've got one person, as you see it in today's world, where you've got one person maybe running 3 or 4 machines in a cell, they're trying to keep the green light on. They need to know exactly what their tool life is going to be. So you get good, consistent tool life with the new head whenever you change it each time. And when it comes to indexing, that's also anytime the green light's not on and the spindle's not running, then you're not making parts. And especially in the medical world, the cycle times can be fairly quickly on items like bone screws or something like that. So you don't want to spend a lot of time changing over your tooling because your machine's not up. And so with the Iscar self-clamp system, it's very quick to change it inside the machine. Basically we say no setup time, but it does take a little bit of setup time. So, but you can see relatively quickly, roughly 19 seconds, the average person is going to change that insert and be able to hit the green button as long as they're not drilling tighter than plus or minus 2 thousandths on the overall length, and be able to go ahead and do it. And if you've got a tool that has maybe screws in the front or screws in the side, it's obviously going to take longer. If your tool requires you, as in the bottom right hand, to take the tool out and to use a drawbar to tighten it, it's considerably longer. And when you put the tool back in, now you have to go ahead and touch off on it again, and you still have that potential to make a mistake in the presetting of it. So again, downtime costs you, and we try to eliminate that as much as possible. So whenever we're looking at these, and like I said, we're always about change. So when we launched the line back in 2009, we launched it with 3 basic heads. We now have, and again, they have different edge preps. And I really tell people, don't get locked into thinking about, well, that ICP, that's for the ISO material group P, and I can only use it for P. That's not true. Think of it more as an edge prep type of thing and the geometry. ICK for cast iron, but you can use it in steels. You can use it in stainlesses. If you have a lack of rigidity and maybe you're chipping, then you can go to a little bit more reinforced edge and different geometries, even a more reinforced, stronger edge. So you've got those 3 main ones that we launched the line with. But since then, we now have a non-ferrous. We have the ICH for 65 Rockwell RC. We have flat bottoms. We have different geometries, different grades, double margin inserts. The ICG is a chip splitter to help reduce horsepower requirements, or if you're in a material that don't like to break a chip, or you have very, very low coolant pressure, it's a problem solver. So now we have 11 standard geometries that will fit within those bodies. And when we look at some of the ones that make us unique, the HCP allows for self-centering where you can drill up to 12 times D without making a pre-hole. It's usually recommended if you're going to go over 5 times D, you need to make a pre-hole. And so the benefit of it is you make a very small, it's only like a 1 millimeter diameter when it first starts to drill. And you can think of it working as kind of like a tailstock on a lathe. You know, you have a very small contact area, but that really helps to stabilize it. Well, the same's true. You make a very small drill hold entry there and it stabilizes it. And then the pressure increases and the forces increase as you get up to your full diameter. So that's one of the geometries we have that's helps to in those situations. Also, it has a large wiper, so if you got to watch it, if your nickel content is too high, this might not be the head that you would want to go with. But it does go all the way down to that 1 inch. To the 157 thousandths or 4 millimeter. And I can show you in the video here that what that does is on a long extension, you'll notice in the body is shaking on the right. That's because we're doing a 12 times D with no pre-hole. And you can also notice that the chips are coming out fractured. On the left, it's same parameters and same 12 times D, but it's very stabilized because we got that initial soft entry penetration to stabilize it like that tailstock. Now, had we drilled a pre-hole, the drill on the right would be just as stable as well. But whenever you have that extra operation, that takes time. And so we're trying to make it be as efficient as possible. Also, if you have issues to where you need a part that's really straight, then we're going to recommend the double margin geometry. And not only that, the QCP is also self-centering where you can go up to 12 times D without making a pre-hole. And it goes down to 177, 4.5 millimeters. And obviously they go up to 25.9. But it's good. It's beneficial if you have parts that don't have a really smooth surface on entrance and especially exit. That's good. Or also if you have a lot of cross holes, then it's good because you have 4 points of contact by having all those margins, and that will help stabilize it, give you a better finish and a rounder hole. So there's a lot of things instead of just a regular old standard drill point and drill. Technology through the years has been increasing with all the manufacturers to give these drills for these different applications. And the beauty of the Sumo Cam is maybe one day you're drilling ones with cross holes in it and you want the double margin, and with the same body, the next day you're drilling parts that don't have the cross hole. You can put another head in there that's not the double margin. And so each one has stronger attributes, and our Iscar sales team or our channel partners can help and direct you into which one's got the benefit over the other one, whether you're looking at surface finish or burr on the exit or best for inclined entrances and exits, things like that. Then we can direct you in that direction so that you get the correct tool for the correct application. And then I mentioned some of the problem-solving type of heads. And by the way, this ICG works very well in the nickel-based materials. All of your Inconels, your cobalt chrome, your stainlesses. It really works well. It splits the chip. It's a sharp cutting edge. And so it helps in those situations. Unless those materials are high heat treated, then it wouldn't be the choice that I would recommend. But by splitting the chip, it reduces horsepower. Also, by splitting the chip, it helps to evacuate chips. If you have a chip evacuation problem, low coolant pressure, material that doesn't do good at breaking chips, then you're able to utilize this and have it break the chip. So it's a problem-solving type of head. And like you'd expect it to, it's going to break the chips into small segments. And that's really beneficial when you're drilling deep, because chip evacuation is always an issue when you try to drill deep. And then you can see in the different materials, you get good chip control. Doesn't matter if it's a carbon steel or an Inconel or a titanium or a stainless. So we can provide chip control. We have flat bottoms. So if somebody needs to make a flat bottom, then that's capable to do so. And it depends on what the part feature requirement is. It does have a very small dimple that's a little under 40 thousandths of an inch in the center. This insert also allows, since it starts with the small drilling diameter, it allows you to use it on up to 12 times D without making a pre-hole. So a lot of options here. And with that, some applications might be in the past, and most people that are doing medical components, I'm sure they make other components too. And they're not just stuck into one thing. And you'll find once you have a tool in your shop, it kind of works its way into other applications and other people use it. So if you have the flat bottom, typically if people need a flat bottom hole, if they're on a lathe, they drill it and they come in with a boring bar and bore it, 2 steps or 2 operations. If it's in a mill, they drill it and then they end mill it. Well, now you can take the flat bottom and just do the flat bottom in one shot. Bunch of different shank top connections. We have the flats, we have the rounds, cylindrical. We have what I want to get down to is we have multi-master. So we have Sumo Cam with multi-master shanks. We have the DCNM right here is a modular system using our Flex Fit Face Contact M12. If people are using our Pico pass cut system, we now have Pico holders. So these three are really new for us. We've expanded them to help make it more versatile and help you get more use out of those systems you already have. And then we have some other custom shanks, but we go from 1.5, 3, 5, 8, and 12 times D standard bodies. And of course, in specials, we can do longer. And so when we look at this and we want to go deeper, we can do it with the 8 and the 10 and the 12 times D bodies. But the 10 times D is the larger sizes, maybe not so beneficial in the medical community. Notice the deflection in that body. Now, this is not recommended because that's a 15-degree angle with no pre-hole. But the point I'm saying is if you had solid carbide and it deflected that much, it would end up breaking. One of the attributes of having a steel body is it does allow some flex, but you still get the performance number of carbide because the business end of that tool is carbide. Now, obviously, we're not condoning this. We're not saying do this. This is just to show you the durability of the body. Don't do this for long term because it's not making good quality holes, and it's destroying your tool life of not only the drill head but the body itself. And so whenever we look at these, and I mentioned in the medical, we keep going smaller because, hey, you don't want a huge medical component inside your body. So everything you start to do is get smaller and smaller. So we went down to 157 with Sumo Cam. They look like jobber length drills. They don't have a flange on it to take up extra space, so we can get a fairly long drill depth and the shortest overall length as possible. And so we call it Sumo Cam Mini, and that's going to be in the 157 to 232 diameter range. It's really a small replaceable insert, but it's still respectable tool life. Now in the video, that's 4340. It's not a material you're going to be using in the medical world, but again, it's coolant through twisted coolant and opens up some doors, some replaceability there, some inner adaptability, and also quick change on the machine to keep the machine up and going whenever you have to replace a dull drill head. And it's simple. The 2 inserts come loaded in a plastic key. You'll get 2 plastic keys. You use it to put them on and off. It's that quick. And you can see it has the coolant ports up behind it. So it's a simple solution. Great in the Swiss and small machining center environments where you're really trying to decrease your amount of downtime and also remove as many possibilities for making errors where you don't have to touch off again. And with that C-style shank, we had customers liked it, but they said, hey, we drill bigger than 232. Well, we try to listen to our customers, obviously. So we said, okay, on small Swiss machines, we know you're limited, and in BT30 machining centers, you're limited with a lot of times that ER16 collet, which can't hold more than, it can't hold half-inch and large sizes. You're limited on staying in that 10 millimeter and down range. And so we went ahead and we expanded the line using that original concept where everything was first on 6 millimeter shanks. Well, we went to an 8 millimeter shank, and then we went to a 10 millimeter shank and increased the diameter up to 390 thousandths. The heads, they're in 1.1 millimeter increments or 4 thousandths. And in the smaller sizes, I mentioned before, we had 11 heads in the regular Sumo Cam, but in Sumo Cam Mini, which is 232 and below diameter, we have 7 geometries. And so again, quite a few options, and they're in 4 thousandths increments. The bodies, there are 3, 5, 8, and 12 times D in the Sumo Cam Mini, twisted coolant. And as I mentioned, we expanded the C-style shank because our customer said, "Hey, I love that, but I drill bigger than 232." And so we took we had the 6 millimeter shank to start out with, which is 236. Then we went to the 8 millimeter, that's 315, and then the 10 millimeter, which is 394. And now we can provide a solution for Swiss machines and where you're limited on your collet sizes up to 390. And so it fits in those ER11 and 16 collets. Also great for live tooling on regular CNC machines. But we have more choices than that because maybe you've already bought into a system and we want to help you get more versatility out of it and utilization. So if you use the Pico pass cut system, we now make Sumo Cam that will fit into that Pico pass cut. So you can use that if you have it. And you may already have it in your shop and you're using it for boring bars or turning or threading. Then now you have Sumo Cam that will fit into it. And it is coolant through. And so you've got that 157 up to that 394 range. You can replace the drill body fairly quickly if you need to replace the drill body. And that includes changing the sizes for changeover whenever you're changing your parts. And also the nice thing about it is once it's in there and you're sticking to that size, you can quickly change the head off and on. And then, as I mentioned, it is internal coolant through. In that same realm of things, we have the next tool, which is multi-master. So maybe you're using the multi-master system, the threaded component with the face contact, and maybe you're using it for milling or T-slotting or something. Well, now Sumo Cam will fit on that as well. Same size range that going down to. And it also fits obviously in all the different holders that you may already have the collets, or maybe you need a long reach, and so you can put it in the carbide shanks to reach and get something. And it's nice because the changeover is fairly quick on your Swiss machine, as you can see in the video there. It quickly change drill diameters, or some people want to, since the heads are small on these small 4 millimeter 157, they may want to replace the drill head outside of the machine and then just replace the whole body with the new head on it. So you have that versatility and those options. And then with regards to the flex fit, this allows us to go a lot bigger. Now you would actually take and put this in the cross slide of the machine, but the flex fit is an M12 connection, face contact. We have the shanks that fit into the block, but it'll also fit into our existing collets or even integral holders if you're on a milling machine. And you've got adapters and extensions to go really long if you wanted to. So it gives you a lot of versatility. But now instead of being in that 4 millimeter to 10 millimeter range or 157 to 394, now we can take you all the way up to 823 diameter, and you can quickly change it on the machine on all those sizes. And the little straight shanks that we have, we keep, I know for the Swiss machines, they'll be metric. So we have the 16, 20, 22, and 25. And then if somebody just wanted to use the quick change system on a regular machine, we have the Imperial 3/4 and 1 inch, and they are plumbed and tapped in the back for coolant. And we also have our collets. I'd like to point that out. So we have some different quick change options for the medical industry there, mainly Swiss machines and small types where it's critical. And we have solid carbide that also fits into the Pico holder. So if you've purchased the Pico system, the Pico pass cut, and you're utilizing it, then you can take and you can use our solid drills that fit in there. And the range on those is, whenever you look at it, is from 118 up to 315. And you can use these just like with the other ones, with the Pico Sumo Cam. You can also use them, since they're round on the end, they'll seal off in a sealed collet. You can also use them in a regular ER collet if you didn't want to use it in the Pico pass cut holder. And so now on these solid drills, coolant comes around the outside of the tool. It's not coolant through, but it is coolant, as you can see in the highlighted areas. And no, it doesn't blast the chips back down in. It doesn't go into the gullets. It stays around the outside of it. So it's between the wall of the part and the outside margin of the drill. And so in the animation, you can see how it comes out and goes around it through those outside points. And then you can see it in simulation here, either going how the coolant's going to come out around the collet or through the Pico pass cut system. And now here it is in real life instead of an animation. And you can see the coolant's not going down inside the chips. It's blasting around the outside of it. And so it allows you, and you can see that it's not clogging up with chips and blowing them back down inside. And within our solid drilling line, Iscar, yes, we have Sumo Cam and it's great for where it fits, but smaller holes or maybe really long diameter ratios and things, we're going to offer some solid solutions. We have a 3-flute multi-master system, which fits all those multi-master holders we mentioned about. They are not coolant through because they're a short drill depth type of tool. And what this is going to do is with 3 flutes, you can go faster. It's going to allow you the versatility of using the multi-master system that you hopefully have already purchased, maybe at some point in time using in other applications. And so it will allow you to take advantage of that. And it provides a good solution for long reach and stability. And since it's a short diameter length, you don't really need through coolant. And it's 315 up to 630 diameter. And the benefit of it is, and this is in the illustration, you'll see it's a long overhang, but a short drill depth. And a regular twist drill, anytime you have a helix, you're reducing the rigidity of the tool because you have to remove the material out of the core. And so, yeah, solid cores are good, but it's better to be in the picture on the left where there's no helix or no flute taking that out of it, because then you're going to have minimum amount of deflection. Minimum amount of deflection is going to translate into higher tool life. And then obviously just an animation of it showing that with 3 flutes, it's a higher feed rate. Then we have our competitively priced solid carbide flash drill line. We have those, they're available, and we have them from 3 to 20 millimeter. We have them in 0.1 millimeter increments from 3 up to 13, and above 13, they're half millimeter increments. Solid carbide provides you a good location if you have a tight tolerance on true position. They're double margin coated, coolant through. We have the equivalent fractional inch sizes as well. We have length diameter ratios of 3, 5, and 8 times D. And as I mentioned, through coolant. And so just a lot of different solutions that we have to kind of help take care of that. And then for deep drilling, and people will say, well, on medical, there's not a lot of deep drilling. Well, proportionally, it can be. And so, for instance, you get some medical devices and things, they may have a 35 thousandths hole, and with that 35 thousandths hole may need to be, an inch or 2 long. So you do get into deep drilling. And so I won't talk about our other solutions because they're all too big in diameter for what would be for medical components. But in the gun drilling world, with the regular gun drill, that does take, you do find that used a lot. So we have solid carbide down to 35 thousandths. We can make 35 thousandths solid carbide up to 16 inches in length. And obviously, within our gun drilling line, we have solid, we have brazed, the indexable and the tulip. The indexable is going to be a pretty good size. We go down to 312 on it. But really, for the medical world, the solid carbide, like I said, it starts at 35 thousandths and goes up to 472. The brazed tip, which would also fall into some of the medical world, would be in smaller parts. They're at the 98 thousandths and up to 1 inch 575. And, with gun drills, you're going to get a good finish in a straight hole. And of course, we can make all kinds of specials and different edge prets and geometries to be custom for certain materials. We can do coated and non-coated. So there's a lot of solutions. But in reaming and medical components, you get into reaming, and we have several solutions here. And in those, we have our MTR solid carbide reamer. They're coolant through. They have a PVD plasma arc, very thin coating, but it allows us to run at really high parameters. So yes, we have non-coated reamers like everybody else, but we really don't want to be that me too. We want to help you be more productive. And so what does these new PVD process reamers provide you is really high speed and reduction in cycle time. So this test report, you'll notice I just want to focus on one thing. It's not a material you'd typically see. It's a steel, so you're not going to have it in the medical world. But a typical reamer, our reamer for that matter, is going to run at 3.81 inches per minute feed rate. But this coolant through coated reamer, we're going to run it at 111 inches a minute. So it's a massive time savings. So again, just a faster solution for doing that. And by the way, those work well in Inconels and cobalt chromes and things, and your stainlesses you're going to see in the medical world. Then we have a replaceable head Bayo T-ream, and this also works extremely well in those materials. And it's a little bit larger diameter, obviously, but sometimes in hip joints and things like that, you have that larger socket piece that gets reamed. And so with the Bayo, it's 6 flute, coolant through, self-clamped in there, face contact. We grind the conical connection, the face, and the shank all in one setting with the proprietary system that takes run out down to 2 microns. And so head-to-head replacement of 2 microns once you've trimmed this thing in and you indicate it in. So, and you can run at really high speeds with it, and that's critical that you have it lined up and the run out is reduced to a minimum when you're going at high feed rates. And you can be in your cobalt chromes and those type of material and be running it at 10 inches a minute or whatever, or 12 inches a minute, which is fast. You know, if you were in an alloy steel, you'd be 80 inches a minute. But you can run it in all those different materials. We have the system is fairly simple. You have the head, the bayonet screw, the shank, and the key. The tool bodies come in standard 1.5, 3, 5, and 8 times D. We can do specials up to 20 times. And there's a range of size heads that fit on one body. So if you take the body and then put the largest head size on it, take the smallest head size and put on it, you may end up with a as high as 13 times D length to diameter ratio off of the 8D body. And so when we talk about the sizes of the different heads, obviously you're not going to get into the biggest ones, but we go down to 453 and we can do specials down to 420. Our standards off the shelf will be a H7 tolerance. They're a 908, or we can do a RN01 diamond coating. That really wouldn't be materials in the medical community. But the H6 tolerance on request, if we're making a special, we're going to use always a left-hand helix to push the chip forward if it's a through hole, so we don't rerun chips and the finish will be great. We'll use the straight flute if it's going to be a blind hole so that the chips can come back up through the top and evacuate. And so, you know, that's our 2 standard geometries that we're going to provide in that. We can make specials with a little angle to them or maybe some kind of little feature on the bottom of it. It is okay for it to go down and touch the bottom of a hole and maybe make a flat bottom. So that is capable. And so, but we can do all kinds of special geometries on the end. The standards, depending upon the helix of the flute, whether it's straight or helix, they'll either be 25 or 45. And so, you know, we have a lot of different solutions there. And obviously, we can't talk about everything, but kind of in a nutshell, that's just a brief overview of some of the products that we have that will fit into the medical community. So,
Awesome. Well, looks like that just about wraps things up, Pat. But any questions that we do get, we will send your way, and you and the rest of the team at Iscar can look them over. But just wanted to say a massive thank you to Iscar for sponsoring today's webinar, and obviously a massive thank you to you, Pat, for chiming in with your expertise and your time. So thank you so much, sir, and I hope you have safe travels back to Texas.
all right. Thank you very much.
You can listen to all of our episodes of Manufacturing Matters and Lunch and Learn podcast from the MFG Radio Network on Spotify, Apple Music, and on our websites, todaysmedicaldevelopments.com, aerospacemanufacturinganddesign.com, defenseandmunitions.com, and evdesignandmanufacturing.com.